Well then, welcome to the translation of the talk Digital Education at School from the 34th Case Communication Congress in Leipzig. We are Pink Dispatcher and Kati, and this is all about making of things. We have a lot of fun doing that, and we want to share this with the younger people as well. And this talk is supposed to tell you how this is possible. And someone gives an example of what you can do with people or children in 5th grade. And we want to give a big hand to Katja Bach, who's holding this talk. Thank you. Okay. Hello and welcome to my talk. My name is Katja and I want to tell you something about digital education at school. And how do you imagine the typical coder, the standard coder basically? Well, yeah, like this, right? She's female, 11 years old. She has polish on her fingernails. And if you actually think about it, you come to the question, can kids, for example, 11-year-old kids, can they actually code? And I want to give you a few examples. The first one is of Wonder Workshop. It's a special robot. It's about Dash the robot. Maybe some of you know that. It's a block-based programming language. The first block is start. The second one is forward 100 and really fast. The third block says stop, and the fourth block says hi. And the question is, can kids do this? Can they code? And so you can see, yes, of course they can. You can see all these small kids, and these are the robots we were talking about, and they can do it without any problem. There's no grown-up with them, and they're just doing it. And the second example, it's from it's the Informatik Beaver. Information technology beaver, and it's all about puzzles. And this task is for kids from 3rd grade on. And the task is you have 2 vents. One is closed, water can't get through, and one is open, where the water can flow through. We have 2 parts of water and 3 flowers. So, which flower gets the water? Yeah, the middle one. And the question is, can these tasks, can kids solve them? And this is no problem at all. These are kids in 4th grade, and they solve these puzzles, and they have headphones on, so they can concentrate on the task, and everyone can do them on their own, and it's no problem. They can do that. So, well, the next example is a robot. It's coded using C++, and there's a small application with 1 task, and Bob 3 set LED I1 white. So this tells the I1 to be set to white. So the question is, if I write one line of code to do this with the I2 as well, and can kids do that? So can they program with text-based And would that be fun for them? And that was also the question. And with this question, there was a model project in Aachen where 7 schools took part, and it's 5th and 6th grade, 14 teachers, and 223 pupils. And they had to be motivated and to be positive about the project. And their first task was to solder the hardware they were supposed to program. So you can see this is a really small board, a small robot, and they soldered for the first time. And here you can see a typical class situation. They had 13 THT parts, and they joined in 2 people for one project, which was quite good because it took out the stress. And if you're soldering this, one is soldering and the other one can put parts in and check if it's on the right spot and on the right side and everything. And that worked out pretty well. So here you can see a different class in a different school, and they did it the same. 2 are working together. And what did they have to do? They had to solder 5 resistors, an LED and a phototransistor to program a special project. There's 2 jumpers and 1 battery holder and a plug. That was basically everything they needed. And doing that in teams of 2, they used about 1 hour. There's a different class. They did this in the computer in the computer lab. Some are faster, and some took the next hours as well. But in general, they usually just took like 2 hours, 2 school lessons basically. And my biggest fear was that was enough for them, and that they are happy with it already. And they were really happy with the project, and even the teacher was really happy. And kids are really, really honest about it. And they was like, okay, I never programmed and I don't really need that. But the target was to have them program stuff. And that didn't really happen because they were really interested in programming.
So here are wooden tables in the working lab, and the pupils who finished earlier, they talked to the teacher, and they got an additional laptop computer so they could look at it, and they didn't really know about how it worked and what programming was or how that should work, but they were very curious and really wanted to do it themselves and really learn how it works and how it's done. That was great. And of course, after that, they really worked in the computer lab as well afterwards. Here's a classroom situation, and in the end, about 6 to 8 double lessons they were programming. And what surprised me with this group was that all of them really wanted to sit alone at the computer, and the teacher had to open a second computer lab because everybody wanted to do it on their own. I thought that was quite interesting that they were motivated like that. And so how do you imagine they're small pupils, and what did they do really? What exactly have they done? And that I wanted to show you so you can imagine, get a better picture of what they did. And exactly, they used a learning environment, a learning platform, and these 2 that we saw on the photograph. And here's the very first introduction. And in the 6th sixth part. And they already learned that there's a setup function where stuff is executed only once, that's in there. And now they are learning, and they shall make one eye turn on and off regularly, just blinking, and they are learning about the loop function. And so things are executed over and over again so that it blinks, turns on and off again and again. And they learn about the delay function, the delay 500. It's the instruction that the controller of the robot waits 500 milliseconds. And we can take a look at that. So the program does the following. Set LED I1. So I1, the first eye is turned on in white, then it waits, and then it turns off again and waits again, and I can show you. And this has to be compiled, and then it should be okay. And here you can see a little blinking light there. And the task was to try different values, and that's exactly the point where the two girls who discussed that, and I walked over to them, and I already had the prejudice that what are they talking about? Are they really talking about the program? I really couldn't imagine that. And they asked me, what do you think better? What do you think is better, delay 50 or delay 500? And I thought, well, what do I have? What's better? Who knows? It all depends what I want to do. And I thought they didn't really understand it. And one of them then said, delay 50 is much too hectic. It's much too fast, blinking. And the other said, delay 500, you fall asleep. That's too slow. And I thought, and I realized that they understood exactly what was going on. They really knew what they were doing. And so small number of milliseconds, wait a little bit, and fast blinking, 500 milliseconds, wait for a longer time, and slower blinking. And I was really surprised that they could do it like that. And I said, so maybe try 200. And I didn't help them, and they did that on their own, and compiled it, and tried it, and loaded it again. And I didn't need to help them. They did that on their own in 5th grade. I thought that was good. And it goes on because it's for school. There's always, in the end of a chapter, there's a small quiz, so that I know in the end. And we can do one quiz here. So what does the instruction delay 1000 do? So possibility A is the controller works 1000 milliseconds faster, or B, the controller waits for 1000 milliseconds. So, well, it's your turn now. And I'll do it. And the second question is, what happens if you remove all instructions from the loop function and put them into the setup function? So I remove all of this and move it to the setup function. So A, nothing changes, or B, I1 remains on all the time, or C, I1 lights once and is then off. Okay, well, let's see. Oh, okay, apparently that was correct. Yeah. So, and now can go into the second one, and it's a little more exciting now. And they should do it, should have the eyes blink alternatingly in yellow. So if one turns on, the other turns off. And this is the program here, which we had in the previous part. That's already done. And we can load that. And works. Okay. And now they needed to program for themselves. So I1 turned on in yellow, and now Bob 3 set LED. And then I2 off, and then wait, and then turn I1 off, it's already there, and I2 turn on, so there we get the blinking effect. Bob 3, set LED. Okay, like this. Let's try that. Okay, let's do it in orange. So you can imagine it like this. They get a small task and had to try that. And okay, yeah, it works. Good. And they could see immediately if it worked or not. And what they really liked, and I can show you, you can select different colors. For example, let's try a different color. Let's try cyan. And the other, maybe purple. Let's just see. And okay, yeah. So that's the way they could do it. And now change the program code so that it blinks faster. Wait, maybe I can do that as well. Okay, so you can play around with it, and the pupils should learn about delay, about the loop function, and really master it a little bit. And the next task is that it blinks a bit slower again. And we don't do that now, but we can look at this at another interesting quiz here. What happens if in this program in line 4 you introduce a delay 2000 in line 4? Insert that. A, the blinking doesn't start because the compiler waits. B, the program doesn't compile because it doesn't make any sense. Or C, the blinking starts after 2000 milliseconds. Or D, after every execution of the loop function, it waits for 2000 milliseconds. Okay. So who votes for A? B? Anyone? C? And D? All right, let's try that then. Okay. There was loud cheers, and it's okay. Okay.
So the question is, what do boys program? And boys are not interested in delays, and boys are not interested in delay 500. Boys are interested in delay 5 million. Yeah, that's right. So what do you think? They type this in, they compile it, and transfer it to the device, and the rest of the hour, well, yeah, they are waiting. That was a bit mean, actually. It's not like this. I can show you something. There's more steps. We would start with the intro 2. And this application was really great for the kids. It is true or false. Bob 3 is supposed to be the finder of the truth. And the kids learn to use if-else tasks. And it's a completely new structure for them. And there's stuff that's asked for. Well, they don't know about this yet, so they are supposed to solve this and to try them out. If this condition is true, then the robot is supposed to has green eyes. And if not, the eyes were supposed to be red. Oh yes, it lights up green, and the tasks are like, for example, if we set this to 1 equals 3, let's see what it does. Well, the kids are asking where this robot knows this from, and you can explain it, and you get some kind of little click moments. They're trying stuff out, of course. What's times 2000? So, what do you think happens in this case? Let's see. So they're trying stuff out, and they can try different stuff from the same cluster. They can just try it and do whatever they want to do. So there's examples what you can try, but they usually get this idea from themselves, what they want to try for themselves. So I won't do this now. And there's also a few questions that are asked and that have to be answered. I want to show you something else that most kids like. They have to make a police car blink, and they are supposed to use knowledge they already have, and it's supposed to light certain LEDs to make it a little more spectacular. And the second part of the application, you have different loops, special loops. So it's supposed to perform pattern 1 5 times, and to flash the eyes light, the eyes red, and to set white LEDs. Well, it performs this 5 times, and there's a different pattern. It's just like flashing. I can transfer this to my Bob, as you can see. So it first makes the one pattern and then the other. What kids like about this and what motivates them is that they can do it themselves. You can see it here. It's always the same functions. For example, the delay, and they learned about this, and I learned this, and they are thinking, okay, I can use this and they can tell the teacher or the parent, see, this is what I did, and I can change the colors. And they are really proud of what they did. They're really proud of showing it off with their own knowledge and their own skills. So on this model project, we had so many kids participating, and there's this evil prejudice that coding and stuff is only for kids interested in mathematics and physics. And we asked kids, and we wanted to know about this. So, do you really like mathematics at school? And it's really more or less evenly. And the other question was how they liked the Bob project. They have 2 hours of soldering and 12 hours of programming, and this is what it turned out to be. So this is really cool, in my opinion. Well, it was really fun to do this with the kids. So no matter how big or small, coding is something you first have to think about, and then you type it, and then it works. And the conclusion is, yeah, kids can do that. They can code. Of course they can. And if you have the right concept, they have fun doing it. Thank you for listening in, and have a great day.
Ja, ganz lieben Dank, Katja.
Oh yeah, thank you, Katja. It's a nice talk. Really, really interesting. And also interesting how to see kids' eyes glowing. We have the opportunity to take some questions. We have 4 microphones in this hall, and there's already queues behind the microphones, and we start with microphone 1.
Hi.
Hi. Katja, thank you for this talk and for your work at schools. I really think it's amazing and it's important to do that. My question is, how can we, I'm not a teacher or something, I'm really interested in this. How can we push all these things forward as a community? Can we go to schools? Do we have to be teacher to do this?
So I think the schools are really interested in that, and that would be in the afternoon probably. So in North Rhine-Westphalia, for example, there's something called ETG. It's ITG, Computer Science Basic Education, and they do the whole spectrum. And they're probably interested in that. If someone comes along and says, "I'd do it," yeah, I could imagine that would work. I would talk to the teachers or to the schools, and if you know about someone, just talk to them and ask them if they need someone to do things.
Well, let's see about the signal angel. Questions from the internet are not available, so next question here. I have a question about the whole circumstances, for example, the sounds compiling and stuff like that. Are they really helpful? Do kids work with it more frequently and they are happy, or is it like, oh, it's cute and kids work with it more easily and have more fun?
Yeah. What I've seen is that the kids like it, and the teacher who has a class of 30 pupils, maybe he'll distribute headphones or says, oh, mute it, please. Yeah, that's what I found. Yeah.
Okay, microphone 2.
Okay, microphone 2, please. Hi. Thanks for this talk and thanks for this project. Were there any reactions from teachers, from ministries of education? Is it better than Excel or HTML programming?
No, not yet. This is a relatively new project. It's only there since October last year, and the model project has just finished. But maybe that'll come. But Excel is important too.
Okay,
microphone 1, please. Hi. I have a pretty serious question. You measured the success of this project, and is there a problem with the evaluation, even if you have applause in the room? Theory is we want to push kids forward to be coders. But does it actually work out? Are there any experiences besides all these trivial applications?
So it's really the case that if you do it with 30 kids, you probably won't have 30 computer science students at university. But we tried it like this, and I would say maybe out of the 30 pupils, maybe 10 are really very interested in that. And I found that's a pretty good ratio.
One question from the internet. The internet wants to know how durable are these robots? How long do they survive?
Well, really, they shouldn't really be dropped on the floor. Maybe they fall down, and I don't really know. I saw it once that someone during soldering did with the tweezers picked off the eye, and it had to be repaired. And well, but most of them really worked, and they shouldn't really fall to the floor. Yeah.
Microphone 4, please. Thank you from my side. I have 2 short questions. Can you tell us something about the robot and the tool chain and the programming structure? Where can we get this and what is it? And the second one is, it's more practical question. The biggest problem, in my opinion, is that the prerequisites are really high. If you have 30 kids in a class, there's a technological freak and someone who never has soldered. And some aren't done after the first lessons. So how do you handle this, especially when you also have the teacher and some other people?
Maybe I answer the second question first. For me, it was surprising to see that it is, as you say, some of them really already started programming or are very advanced in their programming tasks, and the others are just beginning. And I really talked to the teachers, and they know about that. And classes are always inhomogeneous, and there are always these differences. And one teacher, for example, told me that he thinks it's great that even those who are slow, they still just do something, and maybe for an entire half year they just do blinking lights and changing the colors. But he said if he gave them a sheet of math, they don't do anything. So it was surprising that the teacher was actually satisfied with that, and they know about the differences. They have experience with that, and of course you have to take it as it is. And some program at the very beginning, others have started programming a game with the robot.
So if I understand you correctly, you can't really change it, and it will always be like this.
Yeah, that's how I saw it. If you do it with 30 kids in this class, then so if you have a certain working group, there's a selection, a pre-selection, but in the classroom, that's just how it is. What was the first question?
So can you tell us something about the robot? Well, can you tell me something about the robot?
Okay, you can find it on the net. It's Bob3. Just look for it. It's the little circuit board, and this lesson is here. You can find that. The Bob3. And time is up, even if there are many questions. And maybe Katja is available afterward. Okay, today we are here with 8 computers and the robots in the Chaos West. We have our assembly. If someone wants to try that, please come by and try it for yourselves. Chaos West.